Okay, let's start working our way through this classwork. So, warm up number 2 for chapter 3. And we start here with this first one. We want to solve this quadratic equation. And when solving the quadratic equations, we're going to get everything on the same side of the equal sign and see if we can't factor this problem. And so we'll try to factor, no guarantees. And let's see, is it possible to have 6x, 1x, factors of 4 make 5 in the middle. I gotta have opposite signs. I could have 6 and 4 make 2, so that won't work. Let's try 3 and 2. I try 3 and 2. 3 times 4 would be 12. Minus 2 would be 10. 3 times 2 is 6. Minus 4 is 2. Not factorable. So, since it's not factorable, we got to complete the square. So, process of completing the square is actually we need to move that 4 back away from our variables of x. We want the coefficient of the x squared to be 1, so I gotta divide everything by 6. Now we're going to start our square line. So we'd have an x in here. Now, to figure out what goes in here with the x, you're going to half that number in front of the x. So divide that by 2. That makes plus 5 over 12. You're then going to square this number, put it back onto this line here, which is going to make plus 25 over 144. Now, because I put that number on the left, I have to put that number over here on the right. And the right-hand side is going to become 121 over 144. All right, now we're going to take the square root of both sides. Remember, the square root of a square makes the absolute value. This would be 11 over 12. Now we get two cases. X plus 5 over 12 is equal to positive or negative 11 over 12. Then we move the 5/12ths over. We have x is equal to negative 5 over 12 plus or minus 11 over 12. Well, notice we don't have radicals here, so I actually lied at the beginning of the problem. This was factorable because we're going to get two real solutions for x. We're going to get negative 5 over 12 plus 11/12, which is going to be 1/2. And the other solution for x would be negative 5 over 12 minus 11 over 12, which negative 16 over 12, negative 4 over 3. So I guess this problem that we had could have factored to be looking at that. But what would that be? 2x minus 1 and 3x plus 4 would have factored. Could have saved myself some time. 125x to the third plus 64 is equal to 0. So we want to solve this. What we would want to do, we want to find all solutions, real and complex. This is going to be a sum of cubes problem. I see two perfect cubes adding together. I can factor the sum of cubes to a plus b times a squared minus ab plus b squared. Now we need to rewrite the 125x to the third as 5x being cubed. 64 is 4 being cubed. So that way you see what a is and what b is. So we can factor that side to be 5x plus 4 times 25x squared minus 20x plus 16. And then solve. So we can set each factor equal to 0. We get 5x plus 4 is equal to 0. That's going to give me x is equal to negative 4 over 5. Then we'll take our other factor, set it equal to 0. We need to solve it. Now that's always a not factorable trinomial here. So we're going to have to go through the process of completing the square. Divide everything by 25. Pre-make my next line. All right, we're going to half the number in front of the x. I'm going to square it, put it back up here on the previous line. And put it on the other side. And take the square root. Square root of negative 48 over 100 is going to be I. We'd have the square root of 48 on top. Square root of 100 is 10. And we can simplify that square root of 48. So the square root of 48, that is, we'd have, you could say 4 times 12. Square root of 4 times square root of 12, which is going to be 2 times the square root of 4 times square root of 3, which would be 4 roots of 3. And then I can simplify the 4 roots of 3 over 100 and say this would be x equals 4 over 10 plus or minus square root of 3 over 25 times I. All right, write the equation of the polynomial from the graph. All right, well, we identify our zeros and their multiplicities. So we'd have x equals negative 4 as a 0. X is equal to 1 as a 0. That has a multiplicity of 2. And we'd start with y equals our stretch factor times, we'd have x plus 4 times x minus 1 squared. Now, we use this coordinate that we have, which we have a y-intercept at 0, negative 2. So we put in negative 2 for y, solve for a. You get a to be negative 1/2. So this polynomial, negative 1/2 times x plus 4 times x minus 1 squared. All right, let's see. Find g of f of x. So I want to put f inside of g. So everywhere there's an x, I'm putting negative 2x minus 5. All right, now we're on to our current chapter, but some review stuff. Let's simplify the rational functions. Now we simplify, we want to try to get things to cancel out if possible. So I'm going to try to factor. And I could factor that a little bit more, especially that denominator. Now notice we have n minus 5 here. And in the numerator we have 5 minus n. Do a little algebra manipulation. Now 5 minus n is the same thing as negative n plus 5. And I could pull a negative off of that and make negative 1 times n minus 5. And so I'm going to do that. I'm going to put that negative in front of the n plus 6. And I'd have my n minus 5 here. Now I can get them to cancel. And so we simplify it, not much, but it simplifies to negative 1 times n plus 6 over 2n times n plus 3. Okay, look in here. So I want to divide these two rational functions. Before you do the division, factor everything, see if anything can cancel. Remember, if you're dividing by a fraction, change it to multiply, flip the second one. Skip, change, flip. Now I look to start trying to cancel. The x plus 4s are going to cancel here. The x minus 1s are going to cancel. Now that I did the skip, change, flip, I multiply straight across to what's left. We'd have 4 times x plus 2 over x plus 5. All right, now I want to combine fractions. In order to do that, I have to have common denominators. So the fraction on the left is going to get multiplied by the denominator on the right. The fraction on the right side is going to get multiplied by the denominator on the left. And so what we'd have is I'm going to multiply together the tops. 3x squared plus 12x over x plus 3 times x plus 4 plus 3x plus 9 over x plus 4 times x plus 3. Now that the denominators are the same, I can combine the numerators. So we'd have 3x squared plus 15x plus 9 over x plus 3 times x plus 4. Okay, this problem here, people always despise doing these, but when you're working with this kind of complex fraction, what you want to do is you want to go through the process of combining the fractions in the numerator and the denominator. So my numerator, I need to multiply the fraction on the left by 16 over 16 and the fraction on the right by x minus 3 over x minus 3. And in the denominator, same thing but different. I got to multiply the first one by 2 over 2, the second one by x minus 3 over x minus 3, and combine everything. And so in doing that, I'm going to have 32 over 16 times x minus 3 plus x squared minus 6x plus 9 over 16 times x minus 3. And in my denominator, I'll have 32 over 2 times x minus 3 minus x minus 3 over 2 times x minus 3. Now I want to put together the two fractions in the numerator and the two fractions in the denominator. And so we do that, we'd have x squared minus 6x plus, now 9 and 32, 41 over 16 times x minus 3 divided by, we would have 35 minus x over 2 times x minus 3. Here's where you do skip, change, flip. So you write the first one, change to multiply, flip what's on the bottom. Now we look to cancel some things out. I'm going to be able to cancel out the x minus 3's, and I'll have 2 over 16, which is just going to leave me with the 8 down there. And so our answer here, x squared minus 6x plus 41 over 8 times 35 minus x. All right, the new stuff for today is to solve rational equations and inequalities and also look at doing some decomposition. When you're solving rational equations, you want to make all the denominators the same. And it's often helpful to figure out what that's going to be if you factor everything in the problem. So I'm going to factor my problem. And now we look and say, all right, well, what is the denominator I need everything to have? Well, that's going to be n plus 3 times n plus 1. So I'm going to do my adjustments, multiply the fraction over here on the left side of the equal sign by n plus 1 over n plus 1. And that fraction on the far right's got to get multiplied by n plus 3. And then we'll rewrite everything. So we have n plus 1 over the product n plus 1 times n plus 3 is equal to 1 over n plus 3 times n plus 1 minus n plus 3 over the product n plus 1 times n plus 3. Now, since everything has the same denominator in the problem, we're going to work with only the numerators to solve. So we'll have n plus 1 equals 1 minus n plus 3. And solve for n. Okay, I have another one here. It's kind of the same thing. All right, so we want to solve this equation. We need everything. We want to make everything have the same denominator. So we'll factor it and see what we're working with. Now, I need to have the common denominator here of x times x minus 1, which means that this fraction here has got to get multiplied by x over x. Now, that 1 doesn't have either of those denominators, so it's going to have x times x minus 1 over x times x minus 1. And we'll rewrite everything, so we'll have 1 over x times x minus 1 plus x squared minus 3x over x times x minus 1 is equal to x squared minus x. Now, we make an equation with just the numerators. Actually, I only wrote half that fraction. I should have the denominator, x times x minus 1. And so our equation we're working with is 1 plus x squared minus 3x is equal to x squared minus x. Now I want to work to solve this problem. We're going to end up with 1 equals 2x divided by 2, and I get 1/2. All right, rational inequalities. They're similar in process to when we're solving polynomial inequalities. The difference is that we're going to have some undefined values we have to be wary of. What you want to do is you want to fully factor your problem. So I factor my denominator to be x minus 8 times x plus 8. Now you find all of your zeros and your places where you're undefined. Put them in order. So negative 8, positive 8, and 2. Now, make a note to yourself what happens at those numbers. Negative 8 and positive 8 were undefined. So I'm going to write D and E. And when we put 2 in, we equal 0 because it makes the top 0. So now we need a test around those numbers. So let's start number smaller than negative 8. So it's like negative 10. We just want to look to see what are we, positive or negative. If I put in negative 10 for x in the top, negative 10 minus 2 is a negative. Put in the bottom, negative 10 minus 8, negative, negative 10 plus 8, negative. I have 3 negative signs. We're negative there. All right, now let's test in between negative 8 and 2. So like 0. Put 0 in for the x's. 0 minus 2 is negative over 0 minus 8 is negative, 0 plus 8 is positive. So negative and a positive. 2 negatives make a positive. We keep going. Pick a number inside the next interval between 2 and 8. I don't know, let's say 5. Put 5 in for the x's. 5 minus 2 is positive over 5 minus 8 is negative, 5 plus 8 is positive. So times negative times a positive there, we are negative. And lastly, pick a number bigger than 8. Any number to the right of 8 we want. Let's say 10. We put 10 in for the x. We're positive in our numerator, positive and positive in the denominator. So everything bigger than 8 is positive. According to our inequality here, we want to be less than or equal to 0. So I'm going to be less than or equal to 0. So I'm going to be this interval here. Now I can't include the number that makes me undefined. And I'll also be that interval there. So our answers here would be from negative infinity to negative 8, non-inclusive on the negative 8 because we're undefined, union, include the number that makes it equal 0, 2 to 8, exclude the 8 because we are undefined. All right, another problem here. Now, in order to solve the inequality, I have to have one side equal to 0. So I have to do some work here on the front end. I need to get everything on the same side. And then I need to combine the two fractions by getting the common denominator. All right, now we're going to look at this problem and do what we just did before. So since I have one single rational function and 0 on the other side, we'll make a number line here. All the numbers that make it equal 0 or undefined go on this number line. So negative 6 makes the top equal 0. 0 divided by anything other than 0 makes 0. Then we have 3. We're undefined. And we have 4, which also makes the bottom 0, so we're undefined there. Now we test around those numbers. So pick out a number to the left of negative 6. I'm going to go with negative 8. I put negative 8 in for my x's. Negative in the top, negative in the bottom, negative in the bottom. 3 negatives makes a negative. Then I'm going to pick out a number between negative 6 and 3. I'm going to go with 0. Put 0 in for x. We have positive in the top, 2 negatives in the bottom. That means that rational function is positive. Pick out a number between 3 and 4. We'll have to deal with a decimal, 3.5. Put 3.5 in, positive in the top. First binomial is positive, second one's negative. One negative sign makes the whole problem negative. Pick a number out bigger than 4. We can go with 5. 5 plus 6 is positive. 5 minus 3 is positive. 5 minus 4 is positive. Everything's positive here. So now we do what our inequality says. Pick the intervals where you're greater than 0, so we're positive. So it's going to be greater than 4, between negative 6 and negative 3. We don't want to equal 0, so we exclude that negative 6. So we go negative 6 to 3, union, 4 to infinity. Okay, last thing here is the decomposition of rational functions. So basically we're trying to undo the adding and subtracting of two rational functions. The way we start this is you need to factor the denominator. So I factor the denominator. That's going to be x plus 4 times x minus 3. So basically what we're trying to do is we're trying to see what the two fractions were that created that problem. So we'd have one fraction, that would be a over x plus 4, plus a second fraction, call it b over x minus 3. And I want to figure out what a and b are. Well, to figure out what a and b are, you're going to take this line here, and you're going to go through the process of getting the common denominators. So a is going to get multiplied by x minus 3, because that would give it x plus 4 times x minus 3. And b would get multiplied by the x plus 4, when that would give me my common denominator, x plus 4 times x minus 3. Well, that equals negative 3x minus 33 over x plus 4 times x minus 3. Well, this is nothing more than a rational equation. We're going to set all the numerators equal to each other, and we're going to work to try to solve for a and b. So we'd have a times x minus 3 plus b times x plus 4 is equal to negative 3x minus 33. To solve for a and b, what we're going to do, we're going to use a method that's called the cover-up method. So we're going to take the zeros. So to eliminate a variable. So 1 0 is 3, so I'm going to let x equals 3. I'm going to put in 3 everywhere for x. So I have a times 0 plus b times 7 is equal to negative 3 times 3 minus 33. And then we're going to solve for the variable that's left. So we'd have 7b is equal to negative 9 minus 33, which gives me negative 42, divided by 7. I get b is going to be negative 6. So I know what b is. Now, I'm going to do the same thing, but with the other 0. So if I put in negative 4, I'll get a 0. So I'm going to let x equal negative 4. Put that in everywhere. So we'd have a times negative 7 plus b times 0 is equal to negative 3 times negative 4 minus 33. So negative 7a. We have 0 for that b term equals, let's see, 12 minus 33 will be negative 21. Divided by negative 7. A is 3. So what did we do? We figured out what a and b had to be up here in this problem. So basically, the two rational functions that we added together, I would have one of those numerators would be 3. The other numerator would be negative 6. All right, one more. Now, this one's already factored for us. And notice there's also a key difference in that I have a square here. If I have a square and I want to do this decomposition, I have to account for a squared term and a non-squared term. So for instance, I know I'm going to have a over x plus 2, just like what we did before. But now because I have x plus 4 squared, I'm going to have b over x plus 4 and c over x plus 4 squared. Now we'll go through the process that we did before. We need to write everything with common denominator, so I need to show the products. So a would have to get multiplied by, it's going to have to get multiplied by x plus 4 squared. The b fraction is going to have to get multiplied by another x plus 4 and a x plus 2. and the C fraction has to get multiplied by it needs an x plus 2.
Now,
we can work with the numerators. Now we'll do our cover-up method. So we're going to pick our zeros. So let's say, all right, we'll let x equal -2. And then we'll solve. So if I put in -2 for my x's, so I got -8 times -2 squared minus 51 times -2 minus 74 equals, I'd have a times 2 squared, and then I'd have plus 0 plus 0. So I could solve for a. All right, so we get a is going to wind up being -1. All right, then we're going to do the same thing. We're going to change colors. All right, and we're going to do the cover-up method for another 0. So another 0 would be if x was equal to -4. So if I let x equal -4, put back in, I'm going to solve for what's left. We get -1 to be C. Now, notice how we still haven't found B. And this almost always happens when you have one of these factors being squared is you run out of zeros. So what you do to proceed here is you pick an x value. So I'm going to pick an x value, and I'm going to pick an easy one. I'm going to let x equal 0. I want as many things to cancel as possible here. So I'm going to let x equal 0, put in 0 for all my x's, solve for hopefully B. So I'd have 0 minus 0 minus 74 equals, now I have to put a in, because I know a is -1. So I have -1 times, now that would give me 4 squared, and then I got plus b times 4 times 2. Now c is -1, so I say -1 times 0 plus 2. And now I'm going to solve for b. We'll end up getting b to be -7. So what we have done is we now know what a, b, and c are in our problem. So a was -1, b was -7, and c is -1.